So if you try to force a raw, uncompressed 4K camera feed directly into a standard PC during a live event,
It's a disaster.
yeah, there's a very good chance your system is just going to choke, panic, and completely crash.
Absolutely.
So to stream high-end video smoothly, you really need an invisible middleman. And today we're doing a deep dive into exactly that. We've got a product page from HDTV Supply for the A-Neuvideo ANI-USBC4K video capture recorder.
Quite a mouthful of a name, but
It really is a mouthful, but our mission today is to translate this really dense tech spec sheet into plain English. Because whether you're prepping to stream, a massive corporate presentation, or you're just curious about how video creators avoid tech disasters, this hardware bridge is basically the secret weapon.
it is, because the main issue we're dealing with here is just, well, it's pure bandwidth. You've got this massive 18 gigabit per second 4K UHD video set.
And that's with HDR, right?
Right, complete with HDR coming straight from your camera. So this device takes that really heavy signal, passes it perfectly to your local display, but simultaneously scales it down.
Down to 1080p, yeah.
To a much more manageable 1080p, so it can actually be sent over USB to your computer.
Okay, let's unpack this a bit. It's essentially the classic fire hose problem. You have this massive 4K fire hose of data, but your computer's USB port and its processor can really only comfortably handle a garden hose.
That's a perfect analogy, yeah.
So this box acts as a high-tech pressure relief valve. It's out there actively dropping pixels and, compressing the bandwidth in real time so your CPU doesn't just melt down trying to ingest it.
And the really crucial part is that it handles that translation strictly on the hardware level.
Right.
Your PC just receives a nice, clean 1080p feed without dedicating a single CPU cycle to the actual downscaling process.
Which is great when the signal is perfect. But let's talk about the real world, where cables get kicked and HDMI sources glitch out.
Oh, inevitably.
Right. So if that fire hose suddenly stutters, why doesn't the garden hose just run dry and completely crash your capture software?
Well, that comes down to a really standout feature they highlight called video timing stabilization.
Yeah.
In a normal setup, if an HDMI connection drops even for a split second, the sync is totally lost.
The PC just sees the signal vanish.
Exactly. The capture software panics, throws an error, and the whole stream locks up.
Wait, so is this basically
A shock absorber.
Yeah, a shock absorber for your live stream. If someone trips over a wire, your recording software doesn't just freeze up on some weird frame.
Right, because it's maintaining the USB sync internally.
Yeah.
Even if the HDMI input completely drops out, the internal chipset just keeps generating a continuous, stable sync signal to the USB controller.
Oh, wow.
So as far as the PC knows, the hardware is still perfectly connected, which buys you time to, just plug the cable back in without having to restart your whole streaming environment.
That is huge for professional reliability. And looking at the specs, I see it uses UVC and UAC standards. So it's basically tricking the computer into thinking this, massive piece of pro gear is just a standard plug-and-play webcam.
Yep. No custom drivers needed at all.
So what does this actually mean for the user? Is it true plug and play, or do you need an IT degree to figure out which cable to use?
Well, the software side is plug and play.
Oh.
But the hardware side introduces a fairly serious physical quirk. To get that uncompressed, stabilized video into a PC, you really need a modern USB 3.0 port.
Okay, and if you use USB 3.0?
Then the device powers itself perfectly and sends uncompressed video.
But let me guess, if you're stuck on an older machine with only USB 2.0 ports, you hit a wall.
You do. The specs mention it falls back to MJPEG compression.
And MJPEG compresses each individual frame as a standalone image, right? Doesn't that degrade the video quality quite a bit for a pro setup?
It definitely introduces compression artifacts. It's not ideal if you want a flawless broadcast, but it's just a necessary hardware fallback because USB 2.0 physically cannot handle the uncompressed bandwidth.
Plus, there's a power issue too, I'd assume.
Yeah, USB 2.0 doesn't provide enough juice to run that internal downscaling hardware. So you're actually forced to use a special Y cable just to draw enough power from two separate ports at the same time.
Got it. So the takeaway here for you listening is, yes, this TAA-compliant little metal box is an absolute lifesaver, but you really have to audit your hardware first. One USB 3.0 port gives you the uncompressed one-cable magic.
Right.
Anything older, and you're wrestling with extra cables and compressed video artifacts.
It's the trade-off. You have to ensure your machine can handle the output, even if the device is doing all the heavy lifting on the input.
So just to wrap up this deep dive, this device is essentially an auto-scaling, shock-absorbing bridge. It stands between your high-end video gear and your everyday PC, regulating that flow of data so neither system gets overwhelmed when things go wrong.
Which leaves us with a pretty provocative thought to end on, I think.
Let's hear it.
As cameras just relentlessly push toward 8K resolution and massive data rates, are our everyday computers ever actually going to catch up to those inputs natively? Or will hardware downscaling devices like this become permanent, mandatory toll booths on the information superhighway?